So that's this example. Okay, that's good. Let's do another one. So here we're not adding now, we are subtracting. Okay, now notice the denominator here, the first one that is not simplified. The second one is, not the first one. Okay, well, let's factor it. It's not factored, that's what I meant to say. If I said not simplified, I'm sorry. I meant to say not factored. Okay, that's easy to do, right? We have x squared minus a perfect square, 25. So we've seen stuff like this before. We just get x minus 5 times x plus 5, as you can see. That's all we get. And so we have that. The second denominator is factored. Okay, that's good. Let's get the LCD. So we get the irreducible factors, right? The distinct ones, we list them. We have x minus 5, that's listed. We list x plus 5 as well. X minus 5 is accounted for already. Let's look at the exponents. Well, the only exponent of x minus 5 is 1. So the biggest one is 1. X plus 5, the only exponent's 1. So that's also 1. Right? The only exponent's 1, so thus the biggest exponent has to be 1 as well. So because of that, the LCD is x minus 5 to the first times x plus 5 to the first, which is just the product, in other words, as you can see. That's all. Great. From here, what we want to do now, right, we want the denominators to be equal to this. Now, the first one's already there, right? The first rational expression, its denominator is already equal to the LCD. But not the second one. Although that's easy to fix, right? We just need to multiply the bottom by x plus 5, right? That's what we're missing. You know, we want the denominator to be this product. We're missing x plus 5. No big deal. We multiply the bottom by it and the top. We multiply the bottom by x plus 5, and we also do the same thing to the top. And that's what we're doing here. Excuse me, here. We end up with this. And then from here, what we get is this. You know, notice we're foiling the top. Okay? The bottom we're leaving alone because we're going to simplify in the end. The top, however, we foil. So we get this. Right? We have 4x times x, 4x squared. 4x times 5, 20x. Minus 1 times x, minus x. Minus 1 times 5, minus 5. That's good. And so that's equal to this. Awesome, awesome. From here, right, we can now subtract because now the denominators are the same. So we subtract, as you can see, right? We're subtracting. The numerators, the denominators, leave alone. Notice on top also, what I'm doing is I'm putting the second polynomial. I'm using parentheses here. And why am I using that? Because since we're subtracting, you have to distribute the negative. You have to distribute the negative. If you don't, your answer is not going to be right. So I like to use parentheses. So from here, right, once we distribute the negative, we get this. We have negative 4x squared, right, distributing, minus 19x. Minus is plus, so plus 5. Now let's keep going. We have this. minus 4x squared, minus 14x, right? We have minus 4x squared, 5x minus 19x, minus 14x. Minus 1 plus 5 is 4, so we get that. That's what we end up with. Good. Now, are we done? Well, no, because we have to see, is this simplified? That's what we have to check. Now, I factored out a 2 from the numerator. You really don't have to do that, mostly because we're going to use the factor theorem. But I just factored out a 2. I thought it would be easier. It's a little bit easier, as you'll see. Mostly because, again, with the factor theorem, it's enough to check if the numerator has 5 or negative 5 as a root. Right? The numerator, if we replace x by 5 and we get 0, then x minus 5 is a factor. If we get negative 5, then x plus 5 is a factor. Remember, for this, you don't want plus, you want minus, excuse me. So it's x minus a negative. Now we have this. So we check. So we have x by 5, as you can see. Right? We get this. What we get from here, right, is this. You know, I'm just doing calculations. I'm replacing x by 5, right? Again, I want to know, is x minus 5 a factor of the numerator? Right? I'm replacing x by 5 to determine that. We're doing the calculation, and we get negative 83, which is not 0. So x minus 5 is not a factor of the numerator. For x plus 5, remember, you want to think of that as x minus, so x minus negative 5. So now we're using negative 5, as you can see. And again, you replace in the numerator, if you replace x by negative 5, you don't get 0. You don't get 0. Right? You plug it in, you know, you get negative 2 times 25 minus negative, so it's plus 35 plus 2. And you get negative 13, which is not 0. So x minus negative 5, which is x plus 5, it's not a factor of the numerator. So the numerator does not have any common factors with the denominator, any non-trivial ones. When I say non-trivial, I mean not 1 or negative 1. In other words, x minus 5 and x plus 5, these are not factors of the numerator. So this whole thing is simplified. Okay, awesome. Any questions on this? Okay, let's do another one then. Okay. Now we're going to find this sum. Okay, so again, we have to make sure the denominators here are factored, right? We have to first make sure we have a common denominator. Here we clearly don't. You know, they're not the same. So let's factor. This denominator is already factored, right? This denominator. This one, well, it's not quite factored. Let's factor it. As you can see, 36 is 6 squared, right? That's a square. So we actually have a difference of 2 squares here. That's what I'm showing here. We have a difference of 2 squares. We have 36, which is 6 squared. 6 squared x squared minus 1, which is 6 times x squared, minus 1 squared, which is equal to this product. Like you can see, right? We have a difference of two squares here. We have 36 times x squared, which is 6 squared times x squared, minus 1, but 1 is 1 squared. We have 6x squared. So this is a difference of two squares. So we get this. So this factored here, as you can see. Okay, we want the LCD as our common denominator. So we list the irreducible factors, the distinct ones. We have 6x minus 1. That's listed here. 6x plus 1, that's here. 6x plus 1, again, that's already accounted for. You don't list it twice. Now, what are the biggest exponents? Well, for 6x minus 1, we have exponent 1. 6x minus 1 is not here, so we have 1. It's the only exponent. For 6x plus 1, we have exponent 1. Here, the exponent's 2. So because of that, the greatest exponent is 2. So what's our LCD? The LCD is this product. 6x plus 1 squared times 6x minus 1. What we get here.